Okay, in this video we're going to talk about conditional probability along with the general multiplication rule and how to use T-diagrams to model a chance process. Okay. Now, let's look at that homeowner example that we looked at in the last section. And we've got the same data. Let's look at it again. Okay. So now I'm going to ask a couple different questions. I asked a couple questions last time. Now I'm going to ask a couple different questions. You can answer these on your own. Pause the video for a minute and then come back. So if we know that the person owns a home, what is the probability that the person is a high school graduate? Alright, so we know they own a home. So then we only want to consider these people then. Since we know they own a home, we're not concerned with the people that don't own a home. So there were 340 people that owned a home, and 221 of them are high school graduates, so it's 221 out of 340. And if we know the person is a high school graduate, what's the probability that the person owns a home? Well, we know they're a high school graduate. In that case, we'd be using this information. And so that would be 221 out of 310. Well, let's step back and let's formalize this a little more, and let's label our events. First of all, A is going to be being a homeowner, and B is going to be high school graduate. Okay, so here we calculated what's the probability if we know they own a home. Okay, and so we could calculate the probability of A, which we did before. The probability they're a homeowner is 340 out of 500, and the probability that they're a high school graduate is 310 out of 500 from this table. We've done things like that before. But now what we calculated here was what's called a conditional probability. Okay, a conditional probability. Okay? And a conditional probability, and we'll come back to that in a minute. A conditional probability is the probability that an event occurs given that another event is known to have occurred. If event A happens, the probability that event B happens the probability that event B happens given A has occurred is denoted probability of B given, we read given A. The probability of B given A. Now this gives students a little bit of trouble because they're used to reading from left to right. But in this, the second event has already occurred. The one listed second is the one that's already occurred. And we're finding the probability that the other event is going to occur knowing that. Well, we did that already when we looked back up here, and we look back up here at what we have. Okay. So we have our two events, the probability of A, and we did, if we know the person owns a home, so that's the one that's already been occurred. That's the one that's already occurred. So it'd be the probability that they're a high school graduate, so that's the probability of B given A is 221 over 340. Like I said, that's what we did already. Okay. Now, in this one, if we know the person's a high school graduate, so now it's the B, event B has already occurred, so this is the probability of A given B. We know that the person is a high school graduate, and we calculate the probabilities. Okay. That is conditional probability. And how do we calculate conditional probability? Okay, well, it's this. The probability of A given B is the probability of A and B divided by the probability of B. So these have to match here. The B's, B and B, are on the ends there. That has to be true, because you could have the probability of B given A, which would be the probability of A and B divided by the probability of A. So this time these two match. But it's always, they always match the last one there. So let's look at that. Let's look back and see if that worked. We didn't get our conditional probabilities that way, but you will be asked and do questions where you have to do it this way to make sure, they want to make sure you understand the formula, and they will give it to you on the AP test, this formula. Okay, so we know the probability of B given A. Our formula we just learned, the probability of B given A is the probability of B and A divided by the probability of A, right? So the probability of B and A, so the probability that they're a high school graduate and they own a home, well, that's, we calculated that before, it's 221 out of 500. So using our formula, we would have 221 divided by 500 over the probability of A, which is 340 divided by 500. Now we got a nasty fraction here, but nice thing about it, when you have a fraction on top of a fraction, you can cancel between the numerators and the denominators. So this 500 and this 500 cancel, and I'm left with that 221 over 340. Exactly what we got from before. Exactly what we got before. Maybe we can show a similar thing for number 2. We're not going to do that right this minute, though. Okay. So let's look at an example. Okay, we also talked about cell phones and landlines in the last section. Okay. And we filled out our little two-way table. So it says, what's the probability of a randomly selected household with a landline also has a cell phone? Well, we know they have a landline because they told us that. So we're going to use that row. And so the probability, it's the probability of, and we're going to call this L is landline and C is cell. So we want to calculate, since we know they have a landline, it's the probability of C given L. So that's the probability of C and L divided by the probability of L. Well, the probability they have both is 0.51. And the probability they have a landline is 0.60. So 0.51 divided by 0.60 is 0.85. So there's an 85% chance, okay, 85% chance that a randomly selected household with a landline also has a cell phone. All right, the general multiplication rule, okay, we had the general addition rule in the last section where we learned about how to calculate the probability of A or B. The general multiplication rule is to calculate the probability of A and B. Okay. And it actually comes from the formula we just used. It is the probability of A times the probability of B given A. And they will not give you this one, but it's essentially the same as the other one. If you think about the one we had for probability of B given A, is the probability of A and B divided by the probability of A. All they did here was to take this and transform it a little bit to make that. All they did was multiply both sides by the probability of A. Right, so let's do an example. About 55% of high school students participate in a school athletic team at some level, and about 5% of these athletes go on to play on a college team in the NCAA. So what percent of high school students play a sport in high school and go on to play a sport in the NCAA? Okay, so first of all, let's look at these percentages. 55% of high school students participate in a school athletic team. Okay, and 5% of these athletes, 5% of these athletes go on to play on a college team. So if we say H is high school and C is college, what they've given us is the probability that a kid plays in high school is 0.55. The 5% is not the probability that they play. It's the probability that they play in college given that they played in high school, because it says these athletes. So it's 5% of those athletes. So it's not counting the entire school population, only the kids that were athletes. And that is 5% or 0.05. So if we want to calculate the ones that do both, we take 0.55, the probability of H and C is going to equal the probability of H times the probability of C given H. So 0.55 times 0.05, which is a very small number, 0.0275. So about 3% of athletes, high school athletes, play in college. And it's even smaller number when we talk about playing in the pros. 3% play in college. Not a high percentage at all. Not very many. All right. Let's look at a tree diagram. The best way to do a tree diagram is going to look like this. We'll have branches, and we'll talk about percentages and probabilities, but the best way to do that is just do an example. Okay. Alright, so the Kaiser Family Foundation recently released a study about the influence of media in the lives of young people aged 8 to 18. In the study, 17% of youths were classified as light media users, 62% were classified as moderate media users, and 21% were classified as heavy media users. Okay. Of the light users who responded, 74% described their grades as good, while only 8% of moderate users and 52% of heavy users. Suppose we selected a person at random. Okay, we want to draw a tree diagram to represent this situation. First of all, we have to recognize 17% of the youth, and then 62% of the youth, and 21% of the youth. And then it says, of the light users who responded, 74% described their grades as good. That is a conditional probability, because we know they were light media users, and 74% described their grades as good. Now that helps us because we need to make a tree diagram, because there are two things we have. We have whether their grades, good or bad, and light, moderate, or heavy media users. So here's how we do this. We do students And there were three possibilities: light, moderate, and heavy for media usage. And then each one of these, they had good grades or they had bad grades. So we have good and we have bad, and we have good and we have bad. That's our tree diagram. That's what our tree diagram is going to look like. And now we're going to just fill in the percentages here. So it says 17%, 0.17 were light users, 62%, 0.62, and 21% were heavy media users. Now, of the light users who responded, 74% described their grades as good. So 0.74 said their grades were good. Okay. Now, and then that means that 26% said their grades were bad. The moderate users, 68% said they were good, which means 32% said they were bad. And the heavy meter users, 52% said they were good, so 48% said they were bad. Now, we want to, in part B, that's part A, that is our tree diagram. In part B, we want to find the probability that the person describes his or her grades as good. Well, if we knew the probability for each one, light, moderate, and heavy, because those are mutually exclusive, we could just add those three together and we'd be done. Just add them together and we'd be done. Unfortunately, we don't know. So we do know that for the light users, 17% times 0.74 for the light users, 17% were light users and 74% said they were good. And then add 62%, 0.62 times 0.68 plus 0.21 times 0.52. So by doing that, we can calculate that here. Use our calculator here. So 0.17 times 0.74 plus 0.62 times 0.68 plus 0.21 times 0.52. So 0.6566. So about 66%. The answer to this is about 66% say grades are good. Okay. Now, given that this person describes his or her grades as good, what is the probability that he or she is a heavy user of media? So we're calculating for C, we're calculating the probability that they're a heavy user given they get good grades. So this is a conditional probability. So we need the probability that they are a heavy user and get good grades divided by the probability that they get good grades. Well, we just calculated the probability they get good grades. That's 0.6566. We also used the probability of and, they're a heavy user and, well, that's heavy user 0.21, good grades 0.52. We calculated that right here. It was part of our calculation. It's 0.21 times 0.52 is the probability of heavy user and good grades. So we do the math there. 0.21 times 0.52, and we get 0.1092, and divide by 0.6566, and we get about 0.166. So about a 17% chance. About a 17% chance that somebody reporting good grades is a heavy user of media.